Scientists sealed a chamber on the deep sea floor to watch oxygen get used up, and instead, the oxygen levels started climbing in total darkness, where nothing should be able to make it. There was no sunlight. There were no plants. There was no obvious source at all. The reading looked so wrong that the team assumed the instruments were broken. They were not. That result, taken 13,000 feet down in the Pacific, is one of the strangest things anyone has pulled from the ocean floor. It started with a space agency that was never looking for it. This is what NASA actually found at the bottom of the sea. NASA did not go down there for the ocean. It went for other worlds. Jupiter's moon Europa hides a liquid ocean under a shell of ice roughly 12 miles thick. Beneath that ice, the pressure is close to the pressure in Earth's deepest trenches. That is not a coincidence. It is the reason a space agency started building submarines. The deep ocean is brutal on machines. At the bottom of the Mariana Trench, the pressure is over 1,000 times what you feel at sea level. It crushes hulls and implodes cameras in seconds. In 2014, an $8 million robot named Nereus was diving the Kermadec Trench near New Zealand when it lost contact with its ship and vanished. Researchers concluded it imploded. One failure and years of work were gone. That loss forced a rethink. A deep-sea biologist at the Woods Hole Oceanographic Institution, Timothy Shank, argued the old approach was wrong. Build one giant machine and you bet everything on it surviving. He wanted the opposite. Small, cheaper robots sent as a fleet. If one died, another took its place. Shank turned to the people who build small autonomous machines for hostile places, NASA. Together they built Orpheus, an autonomous submarine that weighs about 550 pounds and cost about $2 million to develop. That is roughly a quarter of what Nereus cost, about 4 times cheaper. 2 were built in 2018. The clever part is how it finds its way. There is no GPS thousands of meters underwater. So Orpheus navigates by sight, using a system called visual inertial odometry, developed by NASA engineers. It watches the seafloor below, picks out rocks, shells, and coral, and uses them as landmarks. It also remembers. It stores maps, so when it returns to a spot, it knows where it is and pushes farther. This is close to the technology that landed the Perseverance rover in Jezero crater on Mars. Down here, just like up there, no signal reaches the vehicle. It has to think for itself. In May 2021, aboard a NOAA ship, Orpheus ran a series of dives and covered more than 20 kilometers of seafloor. Every dive is a rehearsal for sending a machine under the ice of Europa one day. Here is why the alien ocean idea stopped sounding far-fetched. In 1977, scientists exploring the Galapagos Rift found hydrothermal vents on the seafloor, cracks where warm, mineral-rich water escapes from inside the Earth. Around them, they expected dead rock. They found the opposite. Tube worms taller than a person, blind shrimp, giant clams, whole crowded communities, none of them living on sunlight. A couple of years later, scientists found hotter vents called black smokers, pouring out water near 400 degrees Celsius. Before those discoveries, biologists assumed every food chain on Earth traced back to the sun. Plants use light, animals eat plants, and so on down the line. The vents broke that rule. Life near them runs on chemosynthesis, where microbes turn chemicals from the Earth into energy. The power source is geology, not light. That changed the search for alien life completely. If life can run on chemistry alone in the dark here, it could do the same under Europa's ice, or inside the warm cracks below Mars. You do not need a star. You need rock, water, and a source of chemical energy. The creatures only got stranger. At deep vents in the Caribbean, NASA scientists from JPL studied a shrimp called Rimicaris hybaceae. These shrimp pile on top of each other, beside chimneys spewing water at 750 degrees Fahrenheit. They are blind. Instead of eyes, they carry heat sensors that let them sit right at the line between scalding death and cool water. Bacteria growing in their mouths feed them. When the shrimp spread out and food runs short, they turn on each other. Researchers found shrimp parts inside shrimp guts. They appear to be cannibals. Elsewhere on the seafloor, methane leaks up through old sediment. Around those cold seeps, eyeless iceworms just 1 to 2 inches long burrow straight into mounds of methane ice. In the Gulf of Mexico, there are brine pools, actual underwater lakes 5 times saltier than the sea, dense enough to form shorelines on the ocean floor. Fish that swim in die. Around the rim, mussels and tube worms thrive on bacterial chemistry. The strangest life is not in the ocean at all. It is under it. In 2006, a team supported partly by the NASA Astrobiology Institute found microbes living 2.8 kilometers down in a South African gold mine. The water around them had been cut off from the surface for tens of millions of years. These microbes draw energy from hydrogen and sulfates produced by radioactive decay in the rock. They have sustained themselves in total isolation longer than our species has existed. NASA does not only send robots down, it sends people. Off Key Largo in the Florida Keys, 62 feet underwater, sits Aquarius, the world's only permanent undersea research station. NASA runs missions there under a program called NEEMO, short for NASA Extreme Environment Mission Operations. Crews live inside for up to 3 weeks at a time. They are called aquanauts. The reason is practical. The undersea world is hostile, cramped and cut off, which makes ITER a close stand-in for a spacecraft. Aquanauts rehearse spacewalks, test survival gear, and run tasks planned for the Moon and Mars. Engineers even adjust the weights each aquanaut carries to mimic lower gravity, so the seafloor can double for the surface of another world. It is not a metaphor. It is a working test for how humans will move, live, and stay alive far from home. Now back to the oxygen that should not be there. A scientist named Andrew Sweetman first ran into that impossible rising oxygen reading years earlier and assumed his sensors were faulty. He kept getting it in the Clarion-Clipperton zone, so he stopped throwing sensors away and started investigating. Across 25 experiments, oxygen inside sealed chambers climbed, sometimes to more than 3 times the starting level over about 47 hours. A second independent method confirmed it. His first guess was biological. Maybe unknown microbes were making it. So the team poisoned the water with mercury chloride to kill anything alive. The oxygen still rose. Whatever was making it was not alive. Attention turned to the potato-sized metal lumps that litter that seafloor, called polymetallic nodules. They pack manganese, cobalt, nickel, and copper, the same metals used in electric vehicle batteries. Sweetman heard someone call them a battery in a rock. The team tested the voltage on 12 nodules and measured up to 0.95 volts on their surfaces. A standard battery puts out about 1.5 volts. The leading idea now is that these nodules act as natural batteries, splitting seawater into hydrogen and oxygen. Rocks making breathable air in the dark 13,000 feet down. That matters because for generations, the story has been simple. Oxygen on Earth comes from life using sunlight. These nodules are not alive. If they make oxygen naturally on the undisturbed seafloor, one of biology's oldest assumptions has a hole in it. Be honest about the limits here. The dark oxygen finding is a hypothesis, not settled fact. And some of the scientists who reviewed it doubt it happens without the disturbance of Allender. That caution is the point. NASA went to the deep ocean to rehearse for alien worlds and kept finding that Earth already hides them. In vents, in brine, in rock miles underground. We went looking for answers and came back with better questions.